and welcome to Math Made Easy by Planet Spark. I am Nidhi and I am back with a new concept, everybody. Last time we discussed some theorems related to circles. Okay, all the 10th graders, it's for you. Tangent से related कुछ theorems हमने की थी last time. Now we are moving ahead for some more theorems related to circles only. So let's get started, everyone. Now, what all do we know about circles? Yes, basics हमने कर लिए, tangents की properties and all, right? So, let's move forward with that. Now, for tangent, we already know that it touches the circle at one point and is perpendicular to the radius, right everybody? Proof भी हमने किया इसका in 9th grade also it's there. Then, two tangents from an external point are equal in length, right? And their angle relationship helps in proofs. Angle relationship भी हमने की है, right? Let's say this is a circle. From an external point, two tangents we are drawing to the circle. We know that these two will be equal in length. Let's say the point is P, here A, here B. This is the center O, right? OA and OB, they will be perpendicular to PA and PB respectively. And if we join this external point to the center of the circle, then we know these two angles will also be equal. Right everybody, ये सारी चीजें हम prove कर सकते हैं by proving these two triangles congruent, which we have already done through RHS congruency. Right, let's move ahead then. Next important theorem है हमारे पास, that is the alternate segment theorem, that states the angle between the tangent and a chord equals the angle that chord makes in the opposite segment. What does it mean? Let's see. Figure देखो यहाँ पे, this is the circle with center O and we have this tangent PQ which is intersecting the circle at this point A, right? Then we have a chord AB here. This is the chord. इस chord और tangent के बीच हमारे पास ये angle है alpha. This theorem states this angle will be equal to the angle subtended by this chord in the alternate segment. What is that angle everybody? That is this angle beta. So, angle alpha and angle beta will be equal. That is what the theorem is saying. So, let's prove it. To prove alpha is equal to beta. Very easy proof. We'll be using the theorems, the concepts that we already know, right? Let's just see then. So, OA क्या है यहाँ पे? OA is the radius of the circle, right everybody? PQ is the tangent. So, at point A, radius और tangent के बीच क्या angle होगा? Yes everybody, quickly in the comments. Tangent and radius, they are perpendicular to each other at the point of contact. So, I can say here, angle OAQ is equal to 90 degree, right everybody? यहाँ से if I want to write alpha, how can I write alpha in term of these angles? Yes, I can say alpha is this 90 degree angle minus this angle, right? So I can write it as 90 degree minus OAB, this angle, OAB. Let's say this is equation 1. Okay, now let's come to this triangle OAB. In triangle OAB, what all do we have? OA and OB both are the radius of the same circle, so they will be equal. Those sides equal hai in a triangle, so we can say the opposite angles will also be equal, right everybody? So, these two angles will be equal. So, in term of these two angles, can I write the measure of this angle everybody? Yes, angle AOB. By angle sum property, sum of three angles of triangle is what? 180 degree. So, 180 degree minus the sum of these two will give me this angle, right? So, I can write here 180 degree minus angle OAB minus angle OBA. दोनों angle equal हैं. So, OBA की जगह again can I write OAB? Absolutely. 2 times OAB I have here. So, directly I can write minus 2 times angle OAB. Isn't that everybody? Now, from here, take 2 common. So, what am I left with? 90 degree minus angle OAB. ये term तो हमने अभी कहीं तो देखी है. Isn't that everybody? Alpha is what? 90 minus OAB. So, here I can put alpha. So, angle AOB I have got as 2 times alpha. Let's say this is equation 2. Okay. Now, in this angle and this angle, what relationship is there? Quickly tell me in the comments. Yes, chord AB, or I can say arc AB, is subtending angle AOB at the center of the circle and angle ACB on the circle. So what is the relationship? Angle subtended at the center will be 2 times the angle subtended on the rest part of the circle, right? So from here I can write, yes everyone, that angle AOB is 2 times this angle, which is beta. Angle AOB क्या है हमारे पास? 2 times alpha. So 2 times alpha is equal to 2 times beta. That means what? Alpha is equal to beta. Hence proved. Right? See how easy it was. We just used what we already knew there. Okay. So always remember that जब हमारे पास a chord and a tangent, between them when we have an angle, that will be equal to the angle subtended by the same chord in the alternate segment, right? So angle alpha and beta are equal. Clear everybody? Okay then. Next, chords, secants, tangents, they follow key theorems. All the theorems that we did there, right? वो सब हम use कर सकते हैं यहाँ, like intersecting chords and tangent and secant there, parallel or perpendicular tangents have, yes, all these properties that we know. So now let's use these properties in solving questions. Here we have the first one. In the figure, ABCD is a cyclic quadrilateral. Quickly tell me in the comments, cyclic quadrilaterals है तो क्या? What do we know about it? Yes everybody. Okay, let me read the question then. Tangents are drawn to the circle at A and C, meeting at a point P outside the circle. Prove that DAB plus DCB is equal to 180 degrees. Okay then. Yes, you all got it? Cyclic quadrilateral means the opposite angles will add up to 180 degrees and all the 4 vertices will be on the boundary of the circle. Right everybody? Okay then. A, B, C, D. ठीक है जी. All 4 vertices are on the boundary. Opposite angles का sum क्या होगा? 180 degree. So from there can we directly say angle this one and this one. That is angle DAB and DCB will add up and give us 180 degree. Isn't that? But since we just did the alternate segment theorem, let's try to prove it using that. Okay. So look at the figure carefully. Can you tell me how can we apply that theorem here to prove this? Yes everybody, scratch your brains, pause the video and write in the comments there. I'm gonna check it. Yes, done? Okay then, let's see. Let me tell you. So, here if you notice, we have this tangent here. Now from a point outside, I can draw tangents to both the points here, to C also and to A also. Let's say just this one tangent I am considering as of now. Same thing you can repeat at this vertex also. Okay. So here what is happening? Yes everybody, if we look at this chord AC and the tangent LM, about these I am talking, right? So if I talk about this angle P, this will be equal to what? Angle R, right? P is equal to R. Why? Alternate segment theorem. Using that, angle between the chord and the tangent is equal to the angle subtended by the chord in the alternate segment. Right everybody? Same. दूसरी जगह apply करते हैं. This angle between the chord and the tangent, इसके लिए alternate segment will be what? In that the angle forming is Q there. So I can say angle S is equal to angle Q. Again same reason, alternate segment theorem. Right everybody? Now here see P and S. Together these are making the straight line. That is, they are forming a linear pair. So I can say from here P plus S, angle P plus angle S, forming a linear pair. So what is the sum of the angles? Yes everybody, 180 degrees. Right? Now P is equal to R. So let me substitute R here. S is equal to 2. So Q. So let me substitute Q here. So angle R plus angle Q will also be what? 180 degree. And R and Q क्या है हमारे पास? Yes everybody. Angle ABC plus angle ADB. Right? In a quadrilateral, if we have sum of 2 angles as 180 degree, so rest 2 will add up to 180 also, because चारों का sum क्या है? Angle sum property for a quadrilateral. All 4 add up to 360 degree. Right? The sum of these two is 180. So the sum of the other two as well will be 180. So from there also we have proved that sum of these two angles will be 180. Right? More than one way is there to prove it. Now that you know all of these theorems, you can use any of them. If you want to know the other method that we used, go back to the video. Okay, 2 videos back in circles for grade 9 we did the exact same question there, right? Proof was different. क्या theorem use की थी हमने वहाँ पे? Yes, we just joined all these 4 here and we know angles in the same segment are of equal measure. So from here this angle and this angle, these two are equal. Same thing we applied 4 times there, we added them up, used the angle sum property, and from there also we proved that opposite angles add up to 180. Remember everybody? Okay then, let's move forward. Next question here. In the figure, a tangent touches the circle at a point A. Okay, this is the circle, center क्या है? O, and this is the tangent, point of contact here we have as A. Clear? Okay. Chord AB is drawn. AB is the chord in the circle. C is the point on the circle. Here we have a point C. If angle PAB is 40, find angle ACB. Okay. PAB, this angle is given to be 40 degrees. We have to find ACB, this angle. Yes, straightforward. Can you all tell me? Yes, everybody, write in the comments. क्या है measure? Within seconds we can tell this is direct application of the alternate segment theorem. Right everyone? क्या है हमारे पास? The angle between chord and tangent, and the same chord is subtending this angle in the alternate segment. Right? So, we can say that angle ACB will also be equal to 40 degree. And that's it. Okay, next one. In the figure, ABCD is a cyclic quadrilateral. Okay, again a cyclic quadrilateral. A tangent at a point A makes an angle of 65 with the chord AB. Okay, between tangent and chord, the angle is given to be 65. ठीक है जी. Prove that angle ACB is 65. ACB, this angle. Okay. Quadrilateral है तो क्या हुआ? Don't get confused. We can still use the properties there. Okay, the theorem that we just did there. We just have to recognize the angles properly. Right everybody? Let's do that. So, if this is the chord that we are taking here, AB, chord AB और tangent के बीच ये angle है. So, it will be equal to which angle everybody? This angle, this angle, this angle, this angle. Which one? How do we know? The angle subtended by this chord in the alternate segment. तो ये segment हम नहीं लेंगे, alternate segment. इस segment में ये chord कौन सा angle subtend कर रही है on the circle? This one, right? So we can say these two angles will be equal. That means angle TAB is equal to angle ACB. Both will be equal to what? 65 degrees by alternate segment theorem. Right? क्या find out करना था हमें? Angle ACB. We have to prove that it's 65. Hence, proved. Just write the reasoning properly. Okay. Next one, everybody. We have cyclic quadrilateral was given just to confuse you. Next one. In a circle, a secant PR and a tangent PT are drawn from an external point P. Secant means it will be intersecting at 2 points. It will pass through the circle. Right? So, ये है हमारे पास the secant. And this is the tangent. It will just touch the circle at one point. Right? Then, points of intersection is given. PQ is 12 centimeter. PR is 28 centimeter. Find the length of the tangent PT. Okay then. Very interesting question. So, how do we do it? Directly, do you know the property? The theorem, the tangent secant theorem, that tells us from an external point, if we have a secant and tangent there, then what is the property? PT square is equal to PQ into PR. That is, the square of the length of the tangent is equal to the product of PQ and PR. And that's it. Substitute the given values there. We have to find the value of PT here. Right? PQ is what? 12. PR is what? 28 PT square. So, length of the tangent is what? Under root 12 into 28. And that's it. Calculation part is up to you. Quickly do it and write your answers in the comment. And that's it. Right? If you're wondering how we can prove it, I am just going to give you a hint what we can do there. This is the center, join it here, right? Then from here, drop a perpendicular and join this as well, right? So what do we have here? You can see some right triangles forming there, right? Play with the Pythagoras theorem there, join all the points and see what all is happening. You will automatically get the relationship that you are looking for. Very easy, everybody. Okay, so this is for you. Okay then, next one. From a point P located 13 centimeter away from the center O of a circle of radius 5 centimeter. Okay, first of all, we are going to have the figure here. So what do we have? A circle given here. For that, the radius is what, everybody? 5 centimeter. Okay then, center is O and point P is located 13 centimeter away from the center. Okay, let's say here we have point P and its distance from the center is 13 centimeter. Then two tangents are drawn to the circle. Find the length of each tangent. So what do we know here? That the tangents will be of the same length, right? Let's say these points are PA and PB. Both will be equal. Join this. 90 degree. This is 5. This is 13. So what we have to do here? Very simple, everybody. Tell me in the comments quickly. Yes, we have a right angle triangle. We can use the Pythagoras theorem. Absolutely correct. So, by Pythagoras theorem, in any of the triangle you can use it. In triangle OBP, let's say in that I am applying it. Okay. So here I can write 13 square is equal to 5 square plus PB square, right? That is the hypotenuse here. Hypotenuse, perpendicular, base, or this you can take perpendicular, anything is fine. 169 minus 25 is equal to PB square. 144 is equal to PB square. So, PB is what, everybody? That is equal to 12 centimeter. So, length of both of the tangents will be what? 12 centimeter. Both are equal in length and that is the right answer there. Okay then, everybody, with that we are done here. Let's quickly summarize what we learned today here. Okay, now we know tangent touches at one point and it is perpendicular to the radius. Two tangents from the same external point are always equal in length. Alternate segment theorem, that gives that the measure of the angle between the chord and the tangent is equal to the angle found by the chord in the alternate or the opposite segment there. Right? Cyclic quadrilateral, in that opposite angles add up to 180. Angles in the same segment or subtended by the same arc are equal. That we already did. And yeah, all these theorems we can use there to prove the questions. So now we know the theorems related to tangents, the properties in the chords in grade 9 and 10. Right, everybody? So try more questions there and let me know if you have any problem there. Right? Thank you very much, everyone. That was all. I will come back with a new lecture right soon and follow for more such videos and content and keep sharing it with your friends.